Hi again everyone, Dr. Tom McNamara back for our course in Prep for College Math. In our last video we were discussing the concept of least common multiple. We're going to look at a related concept here of greatest common factor. And before we do that, I wanted to review something that we talked about recently, and that is finding factors. So let's look at a quick example here where we find the factors of 30. Okay? Now, remember I had this little strategy that I showed you in a previous video where if I needed to list out the factors of 30, I would kind of do them two at a time. One way to get a product to be equal to 30 is to do 1 times 30. 30 ends in a 0, so it's even. Another way to get 30 is to do 2 times 15. You could do 3 times 10. Okay, notice how I'm building it up from both ends. Okay, 4 does not go into 30 evenly. 5 does. You would do 5 times 6. And here you found all the factors of 30. Okay, so these are all the numbers that go into 30 evenly. 1, 2, 3, 5, 6, 10, 15, and 30 itself. So we have 1, 2, 3, 4, 5, 6, 7, 8 factors of 30. All right, so we remember how to find the factors of a given number. So the factors are just a list of things that divide into 30 evenly. And now that we remember how to do that, we know how to find the greatest common factor, or at least you'll understand what's going on. So let me do an example for you, and we'll do the greatest common factor of, let's start with 9 and 12. Okay, so greatest common factor, we will abbreviate that GCF. Okay, so let's start out with GCF of 9 and 12. Okay, so what I'll do is I will look at the factors of both. Okay, if you go back and look at our previous video on least common multiple, you were like, okay, when I wanted to find the least common multiple of two numbers, I started out by listing the multiples of the numbers. Here, I am talking about finding the greatest common factor, so I'll look at the factors of the number. Not too many factors of 9. You have 1 and 9, and 3 and 3. So I'm going to cheat a little bit there. I'm just going to list the 3 once. So 1, 3, 9. Those are the factors of 9. Factors of 12. It has more. 1, 2, 3, 4, 6, and 12 itself. Factors of 12. Okay, notice 1 is on both lists. However, we are looking for the greatest common factor. 1 is a common factor, but it is not the greatest common factor. We're looking for the biggest thing that is on both lists. And we can see right here, 3 is the biggest thing on both lists, so the greatest common factor of 9 and 12 is 3. Okay, let's do a couple more. Let's try 63 and 84. So we're finding the greatest common factor of 63 and 84. So we'll start by listing out the factors as we did before. So 1 and 63. This is divisible by 3. Both of the digits are, so the number 63 is divisible by 3. So it's 3 times 21. It's also divisible by 7. It's 7 times 9. Okay, so I think these actually might be all the factors of 63. 1, 3, 7, 9, 21, and 63. Okay, so let's look at 84. I always start my list with 1, and remember, I like to build it from both sides. Okay. So I got those. 84 is even, so it's divisible by 2. 2 times 42. This is also divisible by 4. Let me see, does 3 go into that? I think it actually does, right? 3 into 84 would go in 2 times. 3 goes into 8 twice with 2 left over. 28. Okay, this is divisible by 4. Okay, let me see here. 4 times 21. If it's divisible by 2 and 3, it's got to be divisible by 6. So 6 and 14. Okay, let me kind of give myself a little more room here. 84, 2 times 42, 3 times 28, 4 times 21. If a number is divisible by both 2 and 3, then it's got to be divisible by 6. 6 is also a factor. And 84 is 6 times 14. If a number is divisible by 3 and 4, it's got to be divisible by 12. And 84 works out to be 7 times 12. Okay, so I've got all the factors of 84 there. Notice I had to cheat a little bit and erase my list to give myself more room because I was working from both ends of meeting in the middle. Okay, so we've got the factors. Once again, we see that 1 is on both lists. Okay, 1 will always be on both lists. 1 is a factor of everything. 1 divides into every number evenly. So there's always going to be something that is in common. The question is there anything bigger than 1 that we have in common? And we actually see, okay, well, we got 3 in common. Great. Oh, we see we got 7 on both lists. But here, if we keep on going, remember, check the entire list. We're looking for the biggest thing, and we see right there 21 is on both lists, and that is the biggest thing on both lists. So the GCD of 63 and 84 is in fact 21. Okay, greatest common factor. So make a list of the factors, look for stuff that's on both lists, pick the greatest one, greatest common factor. Okay, I want to do 2 more examples for you. We'll find the greatest common factor of 81 and 125. Okay, so we'll make our list here. 1 divides everything, 1 and 81. 3 goes into 81, 3 and 27. And 9 goes into 81, 9 times 9. Okay, factors of 81. 1 and 125. 5 and 25, and I think that's it. These are all the factors of 125. Once again, we see that 1 is on this list and there is nothing else in common. So the greatest common factor in this case is 1. Okay. Remember, there will always be 1s on the list. The question is, can we find anything greater? In this case, no. There is nothing greater that is in common to both lists. Okay. So, a pretty reliable way to get the greatest common factor of two numbers. And I did say I wanted to do 2 more examples with you, but I think you get the idea from what we've done so far. So make your list of factors, look for what's in common, greatest common factor. The name tells you how to do it, okay? And as I said, these ideas of greatest common factor, least common multiple, will be very useful when we start to work with fractions and when we start to work with other applied problems later in the course.